Hello everybody, welcome back to my channel. Today's video will be seeing various size dependent properties of nanomaterials. So first starting with chemical property, then followed by thermal property, then you have optical property and electrical property. So electronic property, electronic. So let's start electronic property, okay? So let's start with chemical property. So what we need to understand here is that in nanomaterials, they have high surface to volume ratio. Because of this high surface to volume ratio, what happens is that more number of atoms are present on surface. Sorry for the bad handwriting, I just want to finish quickly. So more number of atoms are present on the surface. So because of this, what happens? Because more number of atoms are present on the surface, the chemical activity, or basically chemical reactivity, increases. So chemical reactivity increases compared to bulk material. So they have high surface to volume ratio, so that means more number of atoms are present on the surface. That means the chemical activity increases. And one more thing is they have high catalytic activity is more. So any reaction, they help fasten up any chemical reaction. So what did we understand? If the size decreases, chemical activity increases. So one quick sum up. So in chemical property, what do we see? Nanomaterials, they have high surface to volume ratio. That means that more number of atoms are present on the surface. That means because more number of atoms present on the surface, that means they have more chemical activity compared to bulk material. They show high catalytic activity, which helps to fasten up any chemical reaction. And so what we see, as size decreases, the chemical activity increases. I'll give you a quick example. Consider a cube, okay? This is a cube, 4 centimeter side. Say its surface area formula is 6a square, correct? So 6a square is the formula, and so 6 into 4 into 4, what is it? That is going to be 16 into 6, that is going to be 96, and volume is going to be a cube of a cube, so 4 into 4 into 4, that is 64. So consider surface area to volume. I said it has high surface to volume ratio, right? So 96 by 64, that is 1.5. Okay, now keep it like that. Now the same cube I'm going to divide into 4 parts. When I divide into 4 parts, each side will be of how much length? 1 centimeter. So now surface area of this is going to be 6a square, that is going to be 6, and volume is going to be a cube, that is going to be 1. Now surface area to volume ratio is what? 6. So as you can see, as we decrease this is obviously not nanoscale. This is not nanoscale, obviously. I just gave an example of how when size is decreasing, the surface area to volume ratio is increasing. So you can see in centimeter range only so much it has increased. Then you can imagine in nanoscale how much it will increase. So as surface area to volume ratio increases, more number of atoms are on the surface, so they become more chemically reactive than bulk materials. Catalytic property issue, which helps to fasten any reaction. Size decreases, chemical activity increases. Okay, moving on to the next one, that is thermal property. So in nanomaterials, what happens is that in nanomaterials, the melting point depends on size. So melting point depends on the size. Here the atoms are not bonded tightly. They have freedom to move freely. So what happens is that the melting in nanoscale, as the particle size decreases, as you see, I have actually sublined my notes, and again I'm trying to make it in my own notes. Okay, so as particle size decreases, the melting temperature decreases. So they can move freely, right? So they are not bounded too tightly to the atoms are not bound too tightly, so they can move freely. So nanomaterials melt more easily than bulk materials. So what did I say? In thermal property, the melting point depends. In nanomaterials, the melting point depends on the particle size. As the size decreases, in nanomaterial the size decreases, right? So size less decreases, the melting temperature also decreases. The atoms are not bonded too tightly here, they can move freely. As a result, the melting is more easier compared to bulk material. That's it. Okay, next coming to electronic property. So here what is happening is that in bulk materials, electrons can move freely. Electron delocalization. In nanomaterials, electrons are confined to a small region or area. Okay, that is electron confinement. So by quantum effect, what happens means, whatever energy bands were there, they become into discrete energy levels. As a result, nanomaterials start behaving like semiconductors or insulators. That's it. So in electronic property, what did we see? In bulk materials, electron could move freely because of electron delocalization. In nanoparticle size, in nanomaterials, electrons are confined to a small region, and that is called as electron confinement. Now, because of the quantum effect, the energy bands become discrete energy levels, and nanomaterials behave like semiconductors or insulators here. That's it. Now coming to the last one, that is optical property. Here what happens means, nanomaterials show different special property on interaction with light. Nanomaterial interaction with light, special behavior, and also they can absorb or they can absorb or scatter light differently. They can absorb or scatter light differently. That they can absorb or scatter light in different colors or wavelengths. That also you can write. Different nano particles emit different color. Why? Because different sizes of nanomaterials scatter light of different wavelengths of light. So what did we understand here? In nanomaterials, when nanomaterials interact with light, they show different properties. They can absorb and scatter light differently. Different nanoparticles, nanomaterials show different colors. Why do they do that? Because different sizes of nanomaterial, what are there? Different sizes which are there, they scatter different wavelengths of light. All of this, say, it's not like all nanoparticles scatter same wavelength of light. Different sizes of light, which are different size of nanoparticles, scatter different wavelengths of light. That's why what happens is that different colors are also shown. So these were the size dependent properties. It's not too hard. For the first time it might be hard to remember, but at least remember the basic idea in each one. For example, I only sum up now. Chemical property. Chemical property, what did we see? High surface to volume ratio. So more number of atoms present on surface, so more chemical reactivity. So better, more chemical reactivity compared to bulk material. You don't have to remember everything. That's the main thing, right? At least remember a few points. And then they show catalytic activity, which helps to fasten any chemical reaction. So the size decreases, chemical activity increases. Next, coming to thermal property. Thermal property, what happens? Melting point depends on the particle size in nanomaterials, and as size decreases, the melting temperature also decreases. Here the atoms are not so tightly bonded, so they can move freely. That's why the melting is easier here compared to bulk. So nanoparticles melt easily compared to the bulk materials. Next, coming to the electronic property. Electronic property, what did we see? That in bulk materials, electrons can move freely because of electron delocalization, but in nanomaterial range, electrons are confined to a small range, that is called as electron confinement. So according to quantum effect, the energy bands come on discrete energy levels. Energy band which would be there, like something like valence band, conduction band, energy gap, that gets converted to discrete energy levels. And after that, what is going to happen? Convert to different energy levels. So nanomaterials behave like insulators or semiconductors. So those points are important. Coming to optical property, we understood that nanomaterials, when on interaction with light, behave differently. They can absorb and scatter light of differently. The different nanomaterials show different nanoparticles sizes show different colors, because different nanoparticle sizes scatter light of different wavelength. That's it. I hope I've done well. If I've done any mistake, just let me know in the comments. Thank you and bye bye. See you in the next one.